So, can you explain what a vaccine is?
So a vaccine is, up to this date, it's a preventative measure to against infectious disease. So in the past, we've used pieces, if not the whole virus, that's either inactive or active. And then we'll inject it in your arm. You'll mount an immune response to portions of the virus, and then you'll make antibodies. And those antibodies are what are protective against either developing the disease, the infection, or developing severe infection. And so anyway, that's what a vaccine is meant up until the last few weeks in the world.
So, what's different about this vaccine?
This vaccine, the COVID vaccine, is different because it's not a inactive or active viral particle. It's just a little tiny piece of its genetic code that we copied from one of the COVID viruses that was isolated from a human being. And then we took that little tiny genetic code and put it into these packages that kind of look like fat globules. But they're microscopically small, really tiny. And when you inject that, that'll go into your cells, it'll merge, and then the genetic code that is in that fat globule that's now in the cell will travel near the nucleus. The cell is typically used to getting genetic material. It does it all the time. And it takes the genetic material and it basically will read it and then create protein out of that. It's called transcription and then translation later. This one is translation. And so once that translation happens, where you translate genetic code to now protein, which is this particular piece of genetic code is on the surface of the COVID virus. That will then be made by your cells, that kind of surface protein, and then it'll be shot out of the cells at a high rate, and you'll just have a ton of this protein loose in your tissues and in the bloodstream also. And then that's a foreign protein. So foreign protein is immediately recognized by your immune cells. You'll make antibodies to that, and then those antibodies are protected.
So, a lot of people, including me in the beginning, I thought that the vaccine was the actual virus in it.
No. The COVID-19 vaccine, the one that is coming from Pfizer, Moderna, these are, again, they're the fat globules that are packaged with copies of just part of the genetic code of COVID. And then that will be translated by your cells into protein. That genetic code piece encodes for a surface protein on the surface of COVID, typically. in the normal virus. But when it's in this situation, it's just gonna your cells are just gonna translate it into that surface protein and then excrete it, and then, like I said, it'll get recognized as foreign. And then antibodies are made against that protein, and then the hope is that will, in this case, prevent you from getting serious disease. Only time will tell if we can understand whether this protects you from getting COVID. At the moment, we know it protects you from getting severe disease.
But I thought that's what this vaccine was for, is for protecting you from getting the COVID-19.
That would be nice, but time tells. We don't have enough data, like time points, on this or on any vaccine to know that.
Well, what's the point in them putting this out now?
Because if you don't do it now, then, I mean, you could keep studying it, but you're just going to have people dying from it. The benefit it outweighs that. The data is showing that it protects against severe disease. That is the thing that is presented in the FDA report. That is what matters.
As a disease, and not because I'm when you say disease, I don't know.
Disease meaning you're going to have a flu, cough, but severe disease meaning I can't breathe, and I'm going to the hospital, and I need a ventilator, and to be intubated.
So that's why this is supposed to protect you from that.
The data shows a high protection against severe illness or disease.
Okay.
But time will tell whether it is protective against actually getting infected. Which is why we still must wear masks even if you get the vaccination. Because we just don't have enough time, because it just came out. Again, you could stop it, not have it come out. But if you do that, and you say you want to wait till we can figure out if it is both protective against getting infected and then also protective against getting severe illness. But, thousands, maybe hundreds of thousands of people are dying while you're studying that. It's not ethical at that point to just hold it. Just because you want to see if it's protective against getting infected. The big thing is what we care about and why the disease is so horrible. COVID is because it can kill you. So if you can put a cap on that, then you solve a big problem, and it begins to become more like a regular, viral infection rather than a deadly one.
Well, you just answered a lot of, because my next question was, why should the public take the vaccine? But you just explained it.
Part of it. The big reason is because, two reasons. One, you can protect yourself against, again, at least we know, severe disease. But two, because of what you've heard as herd immunity, you can protect others. And I've used the example of, if you imagine each person that got the vaccine as a person, as a point, like a dot, and then the dot around anyone that was vaccinated has like a little cloud. One person in the midst of 1,000 that has a cloud and the rest have dots. That cloud is representative of protection, and it's a regional protection, local protection. That by being vaccinated, you protect the nearest people close to you, nearest to you, from getting infected or getting the severe disease. But the more people that get that get vaccinated, will have more clouds than that thousands of the 1,000 dots. And so the herd immunity, if it's even more simple, just say it's 100 dots. 70 of those dots need to have clouds, or in other words, need to have been vaccinated for you to have what's called herd immunity. And herd immunity only comes from a vaccine. It does not come from any other modality, any other way or method. It comes from vaccines. And the historical thought was that if we vaccinate this many people and we protect the ones around them that can't get the vaccine, then they can be protected too by proxy of being close to people who have been vaccinated. That is herd immunity, and that is what's the hope next year in 2021.
Yeah. Okay. So what happens if you don't take it?
If you don't take it, then you have the risk of developing severe disease. And just say that time shows us that this is effective and protective against getting even infected, then that tells you that you have a higher chance, if you don't get it, the vaccine, of getting infected plus getting severe disease. Yeah, your likelihood of getting severe disease is low, but add that on top of maybe you just get infected, then you pass it on to someone else, and they can die from it. It's more than just you, and who knows, you might get severe disease. Nobody knows that, young or old.
And what are the side effects? Because every drug, most drugs have side effects, most vaccines. What are the side effects?
In the Pfizer vaccine, the predominant side effects are what come with any vaccine. So, pain at the injection site, redness, some swelling, some, not even just pain at the exact injection site, but you can have, muscle pain, what we usually all feel after an hour or two of getting a vaccine. You go, it hurts to lift my arm. The overwhelming majority of people, of the 44,000 that were in this trial, got just those side effects. The other ones may have gotten a low, and this is very, very, very low percentage, got maybe a low-grade fever for a few hours, maybe a day. But those are the most severe and major side effects of this vaccine.
Okay. So what do you say because everybody's saying different things. I mean, this is new, and You know, people say different things because it's new, and depending on what kind of information they have, you know, nobody's coming up with the same pieces of information. So what would you say, including me in the beginning, until I started really listening to what you had to say and some of these other doctors, that, you know, they put it together too fast. So it's like, well, how can you trust it? Because nobody has ever come out with a vaccine. Even the doctors and the scientists didn't know that we were going to come out with a vaccine. Because when this first came out, everybody was saying, you know, that it could be years, it could be 10 years before a vaccine. So why should people trust it? You know, that it didn't, because we have had this vaccine, virus for almost a year. So nobody was looking for a vaccine to come out. So, you know, what would you say to somebody that doesn't want to take it because they said it came out too fast?
It's simple. It goes back to the first point of the vaccine, which was that vaccines up until this point have been made basically the same way. Without going into too much detail, you would have, you know, parts of the vaccine, the virus, the actual virus. And you can, you know, take that and then make an immune response to it. You have to make a immune cell clone and find the clones, and then go forward with then how do you deliver the vaccine. And at the end of the day, the vaccine would take so much time. I'd have to go into a lot of detail of how a vaccine is made, but it's not easy. It's not simple. But for this vaccine, the COVID-19 vaccine, it's different. This is just taking, again, a part of the genetic code, copying that, putting it into a package that we've developed before in the past, and then injecting that and seeing what the response is. It's not the same. It's you're not needing to, you know, you're not needing to do anything where you gotta take the virus and then maybe put that genetic code into you know, bacterial cells to make them spit it out, the protein, and get it right, and then modify that protein so that it's as highly recognized by the human immune system. You don't need to do all that. This is just, again, taking the genetic code, which is recognized by all, you know, all cells, and then you're putting that into your cells. And you're not changing your DNA. Now, a lot of people think that you're changing, well, because I've got the virus DNA or whatever genetic code, that when it comes in me, I'm changing my DNA. It's not that. It's what people, you might have heard by now, called an mRNA vaccine. mRNA is very fragile, and we use the word labile, which is just fragile. That means that when you get this mRNA in the cell, it needs to be translated into protein, sometimes within a matter of seconds. I'm not sure of how long it can last in the cell freely, but it's not that long before it gets chewed up and discarded. And that's what's happening. Let's just say that one, genetic code piece gets through and then can be translated into protein. I bet you within seconds, it might even get one more protein read through. But within seconds, then it's going to be chewed up and, in other words, thrown in the trash. How do I know that? It's because that's what happens to mRNA. It happens to your mRNA in your cells every second, every millisecond. This is happening all the time. And this vaccine is mRNA and, again, fat globule that is the package. And then it drops it in the cell. The mRNA is translated into protein. That protein is shot out of the cell, and you make antibodies to that foreign COVID protein. And that is who was working on this initially. They were thinking very smart and efficient, because that's at least in my head right now, that's one of the best ways that we should have and should go forward on how we should make vaccines in the future. They just that it's quick, it's tested, and if you don't trust it, again, know that 44,000 people were in the trial. 22,000 got the vaccine, 22,000 got just basically, you could consider it like water. And in the graph that you'll see the red line there. It is going way up after 7 days of either getting the vaccine, the first dose, or just getting a placebo of water. And the water placebo people, the control people, they just start going way up. And whereas the ones that receive vaccine, they go up from 0 to 7, and then it stops going up and it stays down. Whereas the other one just keeps going up. And that goes on for, I believe it's 120 days. And that shows you that the first dose is providing protection. But we're going to be getting 2 so that we can boost that immune system.
Well, why do you get 1 dose and then, well, not why do you get 1 dose? What is this? What is the second dose doing that the first dose didn't do?
In the immune cells that first see that viral surface protein are making a immune response or antibodies that aren't they're effective, but they're not as effective as they can be. And so when you get a second challenge or a second exposure, which is the second dose, the booster, it's called a booster because the immune cells will then see that protein again, COVID protein, that was translated from the genetic code, and then they will rearrange and refine their antibodies to more highly bind to and neutralize the protein. And so that's how we've operated for most vaccines well, a lot of them. Not the flu vaccine, but like hepatitis, you got to get boosters. And a lot of your childhood vaccines, you have to get boosters because you want it to be refined. The first response is, it's good, but it's not as anywhere near as good as the second one.
Oh, okay. So, is this vaccine, is this vaccine just for the COVID-19? Because you just said earlier that this vaccine is supposed to be where it can stop a lot of the like really bad diseases. So is this vaccine, well, I guess I'm answering my own question.
The diseases, again, it's when I'm saying that, I mean the symptoms, the signs and symptoms due to COVID-19, whether that's minor, moderate, or severe signs and symptoms. I'm not talking about just heart disease that's unrelated, or diabetes that's unrelated. The vaccine, as far as we know, provides protection against COVID-19. If there is enough similarity of the COVID-19 surface protein to other coronaviruses, and the antibodies that are generated against that can bind to that surface protein somehow, maybe a little bit or a lot, then it could be effective against, it can provide protection against other coronaviruses. Will it provide protection, if your question is, will it provide protection against the flu, another virus, hepatitis, another virus, or HIV? No, I just said COVID. I'm talking about influenza, hepatitis, A, B, C, or HIV. No, it will not provide protection against that. But theoretically, it may provide protection against other coronaviruses.
But you won't know.
No, because we don't have coronaviruses are out there, but we've only had, we've had very few pandemics or epidemics from viruses like SARS, MERS, and now COVID-19.
Oh, okay. Well, I think that you explained a lot. So, if you had to rate taking the virus,
the vaccine.
The vaccine. If you have one sentence to say, what would you tell people about taking it?
You likely this is month 12 of the pandemic as a whole across the world. You know your risk, your own personal risk. And I don't mean to the vaccine. I mean to developing severe disease. And as you know, severe disease is highly correlated to comorbidities, diabetes, being overweight, a lot of other things, taking immunosuppressants. If you have risks such as those or others, you have a higher risk of getting severe COVID-19 illness. Therefore, I would highly suggest, given the very low incidence of extremely low incidence of major side effects, and some side effects that are typical of any shot, I would get the vaccine. Given that I have asthma, I have that comorbidity, and then even worse, I have to go into the settings where the virus is prevalent or present, which is the hospital or clinics. I want to and will get vaccinated as soon as they open the my time to get it. Because I know what it's like not to breathe that well, and I can only imagine something, you have this disease and you can't even fix the breathing, like with albuterol. That doesn't work with COVID. It just keeps getting worse and worse to the point which they cannot help you anymore, and you die because you had respiratory failure, or maybe not even that. You have a coagulation issue, which we call a coagulopathy, which is you develop a blood clot and you die from that. That's a high abundance of severely affected COVID-19 patients have clots, whether that's stroke, heart attack, pulmonary embolism. Those all kill you. So maybe your lungs were fine, but you die of a clotting problem or something else. There are other things too. So I'm going to get the vaccine, and even if I didn't work in a hospital setting, I would get it, because again, if you're not even, maybe you don't even have comorbidity, I'd still get it, because we're protecting each other that's near. And if we all, that including me, are complaining about wanting to get back to normal, well, this is, if you want anything, most people want things fast in life. This is the only thing that will come up that is fast. There's nothing else. The masks, they'll help, but you see what's happening now. We have masks, but we just got the vaccine and we're going up like a rocket now in the country and the world. And that's because there is no vaccine. We can do our best with masks. And remember, as soon as you get the vaccine, you still need to wear a mask. We probably won't go back to somewhat normal, and that's normal will be 2022 and beyond, if anything. It won't be 2021. But getting closer to normal, where people are outside more, can participate in some bigger groups, maybe smaller graduations can occur. That's likely the beginning of the fall, end of summer, around there. I'd say fall more so, because we have to get vaccinated, and to provide herd immunity, which will provide an opening for society, you need 70% of your citizenry to be vaccinated, a minimum. Without that, you are going to still struggle with high numbers of cases. So you should get vaccinated. And I think there are only one group that probably shouldn't, maybe two, if you're pregnant, and that's because the data is not clear, not because it's bad for you. The data is not clear for that, but it's also for children too. Children weren't a part of the people studied, so.
All right, well, thanks for all the information. That was a lot, and I can't wait to get vaccinated. I'm not scared, because I want to get back to normal, or halfway close.
If anything, I'd be more unafraid of this vaccine than a lot of the other ones, and I wouldn't be afraid of those either, but because we've been doing them for decades. But the one that you shouldn't be afraid of at all is this one. It's been studied. That's a lot of people, 44,000. And if we would have had any major side effects, you would have seen it. So, yeah, I'm ready to get it.
All right, well, thanks.